Hello friends, this is Himanshu from Code Campaign, and today we are going to discuss about data structures and algorithm and their importance in software developer life. So let's proceed. So what are data structures and why do we even need them? Data structure actually provide us a way to organize our data in the code so that we can perform our most frequently performed operations in the code in a very efficient manner. What are the algorithms and why do we need them? Algorithms again provide us a way to solve a complex problem in a most optimized way. So now let's take a real life example and see how the data structures and algorithm solve those complex problem in a very efficient manner. So let's take this real life example. You all have the Gmail account. Every one of you have created a Gmail account. So you know like this is the Gmail account page where you go to create new Gmail account, and then you have to fill some personal information. You will choose the username or the Gmail account name of your own choice, and then you will click the next. After clicking next, what Gmail will do, it will go through the directory of all the 2 billion Gmail accounts and search if this Gmail ID which you want to acquire is being already taken by somebody else or not. And it does this in the fraction of milliseconds. Okay, now let's take a hypothetical scenario that you have to design this same application, this same searching mechanism, where you will be given a email ID and you have to go through the directory of 2 billion Gmail accounts, and you have to give the response within a fraction of the milliseconds. So we'll take the example of two developers, one developer who don't even know what are the data structures and what are the algorithms, and we'll see how he's going to implement the same solution, and then we'll go see from the perspective of a developer who is very much efficient or has the deep knowledge of the data such algorithm and how he is going to implement it. So we'll see both of those scenario, and then we'll see how the data structure algorithms are are handy and effective to make software developer life easy. Okay, so let's move. So here we are going to take the example of our naive programmer. Let's see how he's going to solve this problem. So as you can see, uh, this is our this is our Google Chrome, where we landed on the page where we going to create the Google account. And as you already know, this is our Google Chrome client, and then there will be a Gmail server. There will be one DB. If you're not understanding what is Gmail server, what is DB, just hang on. We are going to demystify all these things in our upcoming videos. If you don't know what the GB is, just consider it as a plain flat file where the account informations are being stored. So suppose this is the file, and then the email ID informations are being stored here. So now you want to uh, create email account which name is jkl at the rate gmail.com, right? So what your client will do, it will send the request to the server to check if the account with this name already exists. Okay, now so what will happen in the background, uh, this jkl at the rate gmail.com will be matched with each and every account name, right? So it will be first matched with the abd at the rate gmail.com. No, this is not a match. Then it will be matched with xyz at the rate gmail.com. No, this is also not a match. Then it will be matched with mns at the rate gmail.com. No, this is also not a match. Then it will be matched with jkl at the rate gmail.com, and this is a match. So at this time, uh, we will get yes from here and here, and this guy will say yes, and then our browser will say okay, this Gmail ID exists, pick something different. Okay, so this is how it works. Now as we can see, four we have only four accounts here, and we have to do four comparison, right? So in case of the Google, where we have 2 billion accounts. This algorithm, if we go according to this algorithm, we have to do around 2 billion into 1 nanosecond, and this 1 nanosecond is while we are comparing the time taken by when we compare this with this or this, right? To compare two strings, suppose it takes 1 nanoseconds. Then we have to search through all the 2 billion accounts, so it will be 2 billion into 1 nanosecond, which will be equal to 2 seconds. So now we are taking 2 seconds if we are going manually, right? If we have 2 billion accounts, which is a very slow response. Nobody wants to wait at the page for 2 seconds. It will be a very bad customer experience, and this solution will not scale. So let's see how the programmer who has the deep knowledge of algorithm data structure is going to solve the same problem efficiently. Before that, let's understand how the binary search works. So basically, binary search is a searching mechanism in which we find the elements in the array which is in sorted order. So suppose this is your array, right? And these are the indexes, the array. And suppose we want to find x. We want to see if x exists in this array or not. So how the binary search works? So this is your start index, this is your end index. So what we do, we go into the middle of the array, go to the middle element of the array, and then we compare if the element that we want to search is greater than the middle element or less than the middle element. Okay, so what is the start index? 1, end index is 6, so divided by 2, so our mid element will lie at the 3 index, so we'll go at the 3 index, okay, which is here, and then we'll see, okay, 1 is greater than 4, no, 1 is less than 4. So now we will only search in this array because we know this array is already sorted, so we'll not find 1 here if it is less than 4, so we'll search only in this array. So in this case, our end index will come here and our start index will remain here. So again, what we'll do, 0 plus 2 divided by 2, which is 1, will come at the 1 index, and we'll see if 1 is equal to 2, no. If 1 is greater than 2, no. If 1 is less than 2, yes. So our end will come here. Now again, same thing. Our start is 0, our end is again 0. So now we'll have 0, right? And then we'll compare with 1. Yeah, 1 is equal to 1, so we'll return true, right? So in this case, if you see how many comparison we did, 1, 2 and 3, and how many elements we have? 6. So we have 6 element and we do only 3 comparisons, right? So so actually at each and every step we are we are comparing it with the only half of the array, and we are removing half of the elements of the array, right? So what is the complexity of this algorithm? Is complexity of this algorithm is log n. If you're not understanding what is the complexity of the algorithm, how the complexity of the algorithm is measured, we'll cover it in our upcoming chapters. Right now, just assume the complexity of the algorithm is log n. Okay, so let's conclude the binary search. Now we'll see how the efficient programmer who has the knowledge of algorithm data structure solve the same problem that we were trying to solve. Okay, again we are trying to solve the same problem, right? So we are again trying to create a Gmail account, again Gmail server, database, file. As we have seen in the binary search, the elements will be stored in the sorted order. So here we see all the Gmail IDs are being stored in the sorted order, right? So now again we are trying to create the Gmail ID with the jkl at the gmail.com. It will again send a request to Gmail server to check if that ID is already existing. And let's see how this operation will behave here. So we have index 0, 1, 2, 3, 4, right? And again we'll apply the binary search here, right? So so our mid will be 0 plus 4 divided by 2, which is equal to 2. So we'll come here and we'll say, okay, JKL is greater than IJK. No, JKL is less than IJK. So we'll search here. So our start will come here and is here, right? So again we'll calculate our mid. Okay, what will be our mid? 3 plus 4 divided by 2, which is 3. So which is 3. So we'll come here and we'll say, okay, jkl at the gmail.com is equal to jkl at the gmail.com. Yes. So this guy will send yes here and this guy will send yes here. So now we have seen we are not going sequentially, we are going through mid, and we have 5 accounts here and we have to do only 2 comparison, right? So let's see. Let's now calculate the complexity of this algorithm. So as we know, Google has 1 billion accounts, and to compare two strings, how much time we are taking? Suppose we are taking 1 nanosecond time, right? To go through all the accounts. In the previous case, we took in the previous state we took, if we have 2 billion accounts, we took 2 seconds, right? Now in this case, what will happen? As we are applying the binary search, and we have seen in the previous case the complexity of the binary search is what? Log n, right? So this will be our n. So this will be what? Billion is 10 to the power 9 into 1 nanosecond, right? So what will be this? This will be 9 log 10 10 into 1 into 10 to the power 9, which is nanosecond. So this will come around 10 to the power minus 9. So this will come around 9 into 10 to the power minus 9, which is 9 nanosecond. So as you can see here, we took only 9 nanosecond, and while in the previous case we took 2 second. So this is the improvement of 10 to the power 9 amplitude, right? So as you have seen now, if we have applied the binary search algorithm, we have been able to do we have been able to solve the same problem in only 9 nanoseconds rather than taking 2 seconds. So I hope now you know what is the use of algorithm and the data structure in the real world when you're trying to solve the problems of the very large scale. So thank you guys for watching this video, and we are new channel Code Campaign. The purpose of this channel is to provide you the basic of algorithm and the data structure, and then solve all the problems which are being frequently asked problem which are being asked in the Google, Amazon, Microsoft, Google, Facebook interviews. And I hope after watching all our video you will be able to crack one of these company interview. So if you have not subscribed to our channel, please go ahead and subscribe to our channel, like the video, spread the video. Thank you.